Good morning, everyone. I'm Narmatha, working in Dr. S.N.S. Rajlakshmi College of Arts and Science, the Department of Cybersecurity. So, in today's lecture, we'll see about the continuation of Data Encryption Standard. So, in the last video, we have discussed about initial permutation and the round structure. So, further, we have things that will be discussed in today's lecture. D is expansion permutation. So in this expansion permutation, what we are performing means we have splitted the plain text into two parts, right hand side and left hand side, right? So that right hand side half is expanded to the same length as 48-bit subkey. So it can be considered R as 8 nipples, that means 4 bits each. We are splitting that 48-bit into 4 bits with 8 blocks. So this expansion permutation, it copies each 4 bits into the middle of a 6-bit block. So if we have 6-bit block means within that we are choosing that nibble. The middle of nibble will be chosen. So it copies the end bit of the two adjacent nibbles into the two end bits of the 6-bit blocks. Substitution boxes S. So we are representing substitution as S. So here we have 8 S boxes which map 6 to 4 bits. Each substitution is actually 4 little 4-bit boxes. Outer bit 1 and 6 selects one row of 4. Inner bit 2 and 5 are substituted. Result is 8 lots of 4 bits or 32 bit. So row selection, it depends on both data and key. So based on the key what we have used and the data what we have produced, based on that the row selection will be made. So here we are using the feature known as autoclaving, that means auto keying. So automatic key selection will be done for this substitution process. So the example is given S of 18, 9, 12, 3D, 11, 17, 38, 39. So it is 8-bit block. So we are converting that into 5FD25E03. So like that we are converting by the use of substitution operation. So the pictorial representation of that substitution is given. Each of the 8 S boxes is different. So we didn't have a same value. All that 8 are different. Each S box reduces 6 bits to 4 bits. So we are reducing 6 to 4. So the 8 S box implements the 48-bit to 32-bit contraction substitution. So we are passing 6-bit value. So that will be converted to 4 bits. So then again we are using the key 48-bit. By combining all these things, it produces 32-bit contraction substitution. Next, permutation. So in the permutation box P, so we are performing different rounds. So in that round, we are changing the order and the values what we have passed for all that 32-bit. So if we have an order like S1 to S8 means, that means 8 blocks. So we are splitting 32-bit into 8 blocks. So with that, we are passing key. So here we have 32-bit value. So that 32-bit value is reordered on the other side by the use of permutation. So we have 16 rounds totally. So in that 16 rounds, we are reordering all the values what you have specified. So it increases diffusion and the effects what we have produced. So D is round and full length is given in this picture. So here at the initial permutation we are performing. After that we are performing the round operation. Substitute the values. After substituting the value we are reordering the things. After that we are performing the permutation operation. So at last we are combining left hand side and also the right hand side to get the ciphertext value. D is key schedule. So it forms subkeys used in each round. So initial permutation of the key which selects 56-bit key with two halves 28-bit keys. So here we have 16 stages. So it rotating each half separately either one or two places depending on the key rotation schedule. Selecting 24-bit from each half and permuting them by PC2 for use in round function. So it notes practical use issues in hardwares and softwares. So schedule is represented in this picture. How we are performing the permuted operation and the key insertion, left shift, right shift. Again, we are performing the permutation operation and we are substituting 48-bit key. At last, we are getting the final result. So from this lecture, you can understand about how we are performing the permutation and the substitution for a particular plain text and how it produces the ciphertext at last. Thank you.